Hey y'all, my name is Nem, and welcome to my Lab 2, Revisiting Charge Tapes for Physics 2 at Georgia Tech. Alrighty, so the purpose of redoing this lab is that instead of having a single point charge represent the electric field on the piece of tape, instead we're going to make infinitesimal segments of the piece of tape and use the idea of superposition to add up all the electric fields in order to calculate a total electric field. And some brief overview results is that our total Q is going to be 2.74 e to the negative eighth, which is about twice as large as it was in lab 1, and that's also equal to Q, which I calculated in the force body diagram. Alrighty, so like I just stated, up here on the right, we're going to use superposition, which is the sum of all electric fields, which is equal to the net electric field. And then we need to know how to calculate the electric field of each segment of the piece of tape. So this is an inverse square root law that uses the K constant, the position of the charges, and the quantity of charge on the object. And then we're also going to need Coulomb's law, which calculates the force of the quantity of charges on each object or versus each other. Alright, so for this free body diagram, I'm first going to explain it like a point charge similar to lab 1. So the electric force is going on the positive y-axis, and then the gravitational force is negative on the y-axis. And then I just calculated that the gravitational force and the electric force are equal to each other. And then in the first lab, I had that the charge was 1.35 e to the negative eighth. But then in this lab, based off of an equation that we derived in class, I got that Q was equal to 2.75 e to the negative eighth. And then for an unsimplified version of the free body diagram, here we have tape B, which is going to be on top, and I'm just showing that the electric force, actually, because of each segment that's separate, we're going to use superposition of all of the tiny little arrows pointing up to add up to equal the net electric force pointed up. And then here I just have that the system is the pieces of tape A and B, and the surroundings are all other objects in the room which have a charge or a neutral and can affect the system. Alrighty, so I'm gonna just kind of go through the coding. So something to note is that I did just kind of add this coding on top of the lab 1 coding. So there's some constants that aren't really relevant, but K is going to be the 1/4 pi epsilon, which is a constant, and then G is just gravitational force constant. M is going to be the mass of the tape, Q is the charge, etc. And then N length and nth width is going to be of the piece of tape, and D is the distance between tape A and tape B. And then here I just have this equation from the bottom, which was taken from my equation slide, and the basically electric field function is going to calculate the electric field for every single n, which is a segment of the piece of tape, based on this equation. Alrighty, and then at the top we have initialization, which is where I take 100 iterations of every single electric force and add them together to get the superposition, which is going to be in the hashtag calculate E field based on the equation in the bottom right. And then in the bottom left, we have the electric force equation, and that is also going to be iterated right there for the hashtag calculate the electric force. And then for every 4, it's going to go 1 through 100, and then after it's calculated all those segments, it will display it right here in the next slide. So as I said, this slide is just going to be the electric force and the gravitational force, and the displaying of the results on the next slide, which is going to be a photo of the free body diagram. And so these are just the results, and basically what the coding did was that I guessed and checked the Q until I got a magnitude of electric force and gravitational force was just the same, and that ended up being that Q is equal to 2.74 e to the negative 8 coulombs, which I also calculated earlier. So thankfully those two linked up, but because of our free body diagram, I knew that the electric force and gravitational force had to be the same, and so I just kept guessing and checking Q until it finally worked out. So most of the errors here are going to be the same as lab 1. There were no other forces taken into account. I also could not really account for any neutral forces such as my hand that touched the tape. We assumed that both pieces of tape had the exact same charges for A and B. Also, the number of segments was only 100, and to get the most accurate results, the number of segments would actually have to be infinite, but I obviously cannot do that or the code would have crashed in this example. Okay, and then the what ifs is that what if each tape was a single point charge as is in lab 1 versus the infinitesimal segments as in lab 2. So lab 1 the charge was 1.35 e to the negative 8th versus lab 2 the charge was 274 e to the negative 8th, which is over a 2 times increase, and it was a lot more accurate because we know that pieces of tape are not just a single point in space, but rather multi-dimensional length. And these estimates differ because, kind of like a Riemann sum, infinitesimal segments that can be added together in a superposition segment fashion are going to be a lot more accurate because you can take so many more areas and add them together versus trying to summarize them as one big thing. Thank you for watching.